Hey guys, sorry I'm a little bit late. I'm supposed to be on like at 9 o'clock and it's 9:45. But it happens. Hey Kluwash, how's it going, man? Sorry, I had to rush a little bit. Kluwash says good, working through some Forth tutorials. Oh, really? Are you learning Forth for school, for fun? Forth is the stack-based language there, right? Imperative stack-based computer programming language. I remember reading about this and thinking it looked pretty cool. The whole concept of programming to a stack and having very, very few instructions, but yeah, it's very interesting. Kluwash says, yeah, it's a university course in stack-based languages, on stack-based languages. Yeah, I didn't do that in university, stack-based languages. But it's very interesting. I think I like how it teaches you to solve problems in a different way. And I think the advantage of Forth when it was implemented was that it allowed for very, very simple hardware, for very simple processors to be built with few instruction sets. The programs themselves would be longer, but the actual hardware for the CPU would be much smaller and simpler. So I think that was kind of the idea behind it. So yeah. All right. So what did I want to talk about? Oh yeah, so yes, so a couple of nights ago, I don't even remember where I was. Let's see, the 6th, implement overlay support. Yeah, so I committed the overlay support, which works, but still needs some work. Let's see if I can show that. Yeah, I'll show it after. Then since then I just did some stuff. Fix black screen when overlay is not found. Oh yeah, so I tested if there was no overlay, that it was actually rendering all black. Did some cleanup stuff. Enabled DPI awareness for Windows 8 and up. That's for my laptop where it's a high DPI, and I needed to constantly make I had to always modify the manifest so that it's DPI aware for Windows. I was able to actually just add a manifest file into a CMake here, and it worked. So, and then last night, at midnight, I decided to have a little fun and just quickly integrate Dear ImGUI. So I don't know if you guys know what Dear ImGUI is, also just known as ImGUI. It's this really awesome immediate mode GUI library. So yeah, it's pretty awesome. Like it's very small, very simple, and allows for really quick GUI building in a immediate mode way, which is a whole concept. So here you can see some of the examples of like fairly complex looking UI you can build with ImGUI. And it's all cool because it's like rendered natively, right? It's like using shaders and in my case OpenGL. So it's not like, you know, this is totally portable, cross-platform. You don't have to worry about like the native windowing APIs. Yeah, it's pretty impressive. And of course there is, you know, some overhead to using it, and it's not the kind of thing I think, you know, you'd want to use. I was gonna say in a professional application, but why not, right? I mean, here you can see it's being used in a game editor. It's got a menu and everything. yeah, it's pretty cool. So let me show what I did. So I just integrated it here, and again, you know, I talked about this last stream. Yeah, Cluwash says mGUI is so straightforward. Totally. So I spoke about this last stream, how like I wish I had discovered or looked into a VC package. Where is it? Got it here. This thing from Microsoft. This package manager tool, because I literally just like VC packaged install. I think it's here still. I did a VC package install mGUI with the triplet x86 Windows static, like with all my other ones. And then in my CMake file, I had to add a find mGUI.cmake because unfortunately, at least the CMake version I have doesn't have it. Maybe I should update CMake. Maybe it has it now. I don't know. Anyway, so I added that, and then in my CMake list, I just added a dependency, a find package for mGUI, and it found it, built it, included. I have the include path in mGUI library here. So it took me like maybe 2 minutes, and I had mGUI in there. The one thing that was a bit more complicated was I had to, like, mGUI has these header CPP files for like how to easily bind mGUI to your specific environment. Like for me, it's SDL for OpenGL3, so I use this header in CPP. There are different ones that you can use. So these are provided by mGUI. I had to make a couple of minor modifications for it to build. There was some warnings related to Windows NT headers and stuff. But after that, the integration was really nice and simple. It looks like this. Let me just bring it up. So there's that special header for the mGUI implementation for SDL GL3. Once I initialized my GL windows and stuff, I call this mGUI impl SDL GL3 init, and I pass it the SDL window. I have this font global scale thing that I'm playing around with because on my high-res display, I needed to double the scale. So what I'm going to do is I'm going to make this an option. I have this little options file, so I'll just add an option there, and it'll be 1 by default because that actually is more common, and I know you can scale it up on high DPI displays. Then after that, in your SDL event loop, you just have to call process event here with the SDL event, and that's what it uses to do things like capturing mouse movement and keyboard keys and stuff like that. Then you have this is basically the core. In your loop, you have to do a new frame, and if I'm not mistaken, this is the place where it kind of like, you know, clears all the immediate mode structures that it's using. Kind of like clears the list of things it's going to render, but I think it keeps a cache for performance reasons of the things that you have added in the past, so that it can not waste time recreating them. And then after that, you run your code, and then you just need to call render at some point when you render your stuff. I think last, so that it renders on the top. That kind of makes sense. Okay, so that's the part of just kind of integration. Then there's usage, and I have this one example here. I went into my GL render and I added a slider, a float slider for the darken speed scale. So this is a value that I passed to one of my shaders for the rate at which we darken. And I'll show you what that looks like when I run it. And I also have one for the overlay alpha, so I can play around with the alpha for overlays, right? And this is exactly why I wanted mGUI, because I was, you know, putting breakpoints and messing around with these static floats in the debugger, and this wasn't fun. I didn't get the immediate feedback that I would like. So this is what it looks like. Okay, so here it is. So here's the overlay. I think Cluwash, you didn't see that, right? The overlay. So this now allows me, this is the mGUI menu here, and allows me to play around with the overlay alpha, which I think is kind of neat. And then the other one, which is really cool, is the darken speed scale. So I'm going to show you what that looks like. So like if I put it to 0, what it means is that we just don't darken, right? So we just basically make a big mess. Now if I bump it up a little bit, you'll notice how the screen slowly darkens now, right? This basically the darken speed scale controls at what rate we want to darken the screen to black, right? Now, if I put it really high, things really flicker. There's absolutely no trails anywhere. We're like darkening it so quickly that, you know, it flickers just a lot. You know, if I take off the overlay alpha, you can really see how interesting. There's even like this kind of weird reddish hue there. Oh, I guess actually I don't really know why, to be honest. That might be related to the overlay actually in some strange way. Oh, you know what it is, I think? I think it's because I might be missing a clamp actually in my shader. Let me just check something. Kind of surprising. So that's for my draw. No, not draw vector. Draw. The draw texture? What? Yeah, so here I'm doing 1 minus overlay alpha, and then I'm subtracting that from here, and I'm not really clamping my ratio here. This means that I could be producing a negative value for my ratio, and I think that might be why we're getting a weird color there. So if I make sure that subtracting here gives us a max of 0 and this, that might solve that problem. Yeah, looks like that was it. Kluar says, huh, that looks pretty awesome. Which part? The overlay, or just the, or like the fact that when we play with the darkened speed scale that it does this kind of cool effect? I think it's cool, you know, like you just watch the asteroids and get to play around with this effect. Like when, if I put it really exaggerated like this and die, watching the ship, it's kind of fun. The big ship here that drops the stars, and the way the stars kind of have this beautiful trail. Anyway. So yeah, one of the things that's wrong here is, and I spoke about this last stream, is, so it's cool with the overlay, but actually what I came to realize is that the overlay is not supposed to be perfectly fitted to the game screen. And you can kind of tell because like there's a score up here and there's like these two, you know, how many lives you have left on here, and these are completely hidden by the overlay. And the reason for that is that the overlay physically on a real Vectrex is bigger than the screen. The screen actually, you know, if you follow my mouse here, usually is like inside the space here. So it's not, you know, as big as it is here, and it's curved as well, right? The screen itself is a CRT, so it's kind of got this curve. So, Kluar says both, but mainly the overlay. Yeah, it's pretty cool. I mean, it was super simple actually to add the overlay. So yeah, all that to say is that, you know, I kind of was thinking about what I want to do, and I want to scale the screen portion to kind of fit better within the region under here, under the overlay. And I'm not in, and like ultimately I also want to do the curves of this CRT, but that's like secondary to me. And I'm not quite sure yet how I'm gonna attack the problem of making the screen smaller. Thinking about it, you know, like I'm thinking it's got, I should be doing something with UVs and like remapping the UVs in the shader, in the vertex shader. So right now I don't even think, I'm not even processing UVs at all. So I think what ends up happening is you just kind of get the default UVs. I'm not really, I'll be honest there, I'm not like an expert on like managing UVs through the shaders, and I haven't done that much, so I just have this feeling like I need to do something there. I mean, there are other ways I could do it. I think I could mess around with, you know, the viewport, for example. Like instead of doing it here, I could do it at, you know, at the viewport level and just say, like, if I just want to keep it rectangular, I can just say my viewport is a smaller portion of the texture, and it'll just map inside there. So that would be kind of a simple way to get it done and working. But then I can't do the kind of, you know, warping to make it look more curved and stuff that I would like to do ultimately. So there's that. I mean, another way I could do it is to kind of have like a more detailed mesh, right? Rather than have, let's say, two triangles, I could basically have a more detailed mesh that actually has the shape I want and render that. But again, that's like, you know, lots of verts, and I'd have to author that mesh, and, you know, it need a lot of vertices to be really curved and stuff. And I think that's not really the right solution. I think the right solution is to just warp the UVs so that it ends up looking right. So that's sort of what I'm thinking. Actually, I'll be right back. I'm just gonna go. I think my coffee's ready. All right. So yeah, I have this list somewhere. Things I wrote down. So yeah, there's the to-do list. Overlay versus screen size mismatch. CRT screen is smaller than the overlay. C armor attack for lining up buildings with overlay image. Sorry, I'm making a mess here. Okay. I also have, so yeah, this I'm just not sure, you know, like I said, I'm like thinking about, you know, UV mapping in Vertex shader. Yeah, I don't know. Is it in the Vertex shader actually? I don't know. You know, maybe it should be done in the fragment shader. Yeah, because I have the UV here. Yeah, maybe it's actually here where I would take the UV and based on the actual UV value, which we know would be some kind of screen space value. Actually, I don't even know what the values are. I guess it's in 0 to 1. That would make sense. Like in UV texture space, right? Where 0, 0 is bottom left corner and 1, 1 is top right. And basically it'll be in that range. And like maybe all I want to do is like a simple transformation to, at least initially, to bring it down, to scale it down, right? So like a scale around the center. So if I take the values and say I offset it so that it's in minus 0.5 to 0.5, then divide by, or like multiply by a scale, and then shift it back. Is that the right way to do that? I think so. Kluar says I suppose so. Let's try. Scaled UV is equal to Like let's take UV minus 0.5 divided by, sorry, let's say multiplied by 0.9, let's say. So this minus 0.5 is like that. Yeah, don't mind the highlighting and stuff. I'm using this tool for HLSL and it doesn't understand GLSL, so it does a little bit of syntax highlighting and then underlines a whole bunch of things that says, hey, this is not recognized in HLSL. So anyway, then we add back this, and then we use scaled UV here. Let's see if that works. I don't know. Actually, no, sorry. We want to do the scaled UV on the rendered texture. I suppose so, right? And I actually, I guess we do want to do it on both. No, we don't. I don't know. Oh, it did something. Maybe I did it the wrong way. Interesting. It's like it made it bigger. Kluash says, let's hope we won't get scaling artifacts. Yeah, that's true. Just surprised. Let's just try half. Wow. So it's like the opposite? Like 0, let's say like at 0, 0, if you take 0 and you say 0 minus 0.5, it's negative 0.5, and we want to scale this. Isn't that right? So like 0 would become 0.25. What about 1? So 1 minus 0.5 becomes 0.5 times 0.5. Whoops. 0.5 is 0.25 plus 0.5 is 0.75. Yeah. Am I like doing something weird here? Take the current UV value, subtract 0.5, put that in parens. Multiply that by 0.5, then add back 0.5. Puar says, I think the problem is that this isn't the screen UV as we imagine it, but we use this UV to access the texture, right? Like it's too late, right? By the fragment shader, is that what you're saying? Mm-hmm. So basically, for example, if we're doing 0, 0, it's still trying to shade the pixel at position 0, 0. Right. Okay, yeah, that makes sense. So actually then, in that case, would it actually work to do this? For shading, it actually does work. Because we're sampling outside the texture space, right? And if there's no wrapping, it'll basically get a 0 pixel. Ah, it's fascinating. So like that's like one way to do it, right? But probably not the right way. It feels like it feels like. Well, no, maybe it is the right way. I don't know. Or maybe it's like a combo, you know? Like there's a part that's in my mind that's like we're sending these triangles in, and these triangles are filling up the screen. And what we really want to do is we want to move those triangles. We want to scale down those triangles, right? And I mean, I guess I could do that on the outside and just make those verts not be at the corners of the real screen. So really make it smaller. And then we can use UVs to like just kind of warp within that rectangle the kind of curvature we want. So let's say this was 0.9 because 0.5 obviously we got lots of artifacts there. No, still not good. Okay, this is starting to look a bit more like the right size. Although I don't think Mindstorm would have been over it. Although I don't even know, maybe it was. But yeah, it's like we're losing a lot here in the downsampling. Wow, this looks so bad. And it's interesting what happens then when we get to the edge. Like when we move outside the... Oh, I guess that's the clamping that's occurring. Huh. Fascinating. Yeah, this is definitely not the right solution. Draw vectors. So like if I was to compute a UV here, I could do the scaling here. I don't even remember how to do that. If we wanted the here it gets input UV. Do I just say out vec2 UV? What just happened? But then I'd have to pass in UVs, right? Based on modulo? Yeah, so Clutch is saying, I'm wondering how that even worked without passing it from the vertex shader. So from what I understand, if you don't pass in UVs, the shader is able to compute it itself. And I don't even know how that works, but maybe it works based on screen space. Like, it does work though, and I mean actually like this question here about, I think right here, as part of an assignment I'm writing a fragment shader in which I am accessing a texture which comes from a fragment buffer. As such, I cannot get the UV coordinates from the vertex shader, which means I need to compute them. Does this kind of imply that it's getting, I think, see here too, he's got a input UVs, and I'm guessing he's getting those automatically. not useful. I don't know what I should be looking for. Maybe texture coordinates? I'm not quite sure. Like I'm not finding the information I'm looking for. But I mean, I think that's how it would work. You pass these vertices and then they get transformed into screen space, and if you didn't pass UVs, I think that in GLSL or maybe it's all shader pipelines, I'm not sure, but they would basically just give you the, like, they use the normalized screen coordinates and then transform them into the, you know, UV range. So you're basically getting the UV of the, like for each vertex is the UV of that vertex in screen space, so to speak, if that makes some sense. But now, of course, if I wanted to compute one from here, yeah, I really don't know what I'm doing here. You know what? Let me look at some of those samples. Maybe it'll clear it up. And this is where you see that I'm really not a graphics guy, right? I'm just learning this stuff as I go. OpenGL tutorials. Maybe basic shading? Where is oh, here. But that's actually what's fun about doing projects like this, is getting to learn technologies that I haven't really played with. So I haven't done much shaders and I haven't done any in GUI, so it's fun to touch these technologies. Okay, so this is the standard vertex shader. So here's the vertex UV, and then there's the out of UV. So this for sure is passing in UVs, right? Would make sense. Go take a look at the tutorial code. By the way, I can't say enough that how great these tutorials are at OpenGL tutorials. I just love playing with code and being able to, it all builds cleanly, and that you can modify it. It's really awesome. It's a great resource. Okay, so here we go. UVs. So there's the UV buffer they created. Buffer data are the UVs, which are up here. Yeah, so when they load the object, this is the same as the other sample we were looking at. They load this object and they get the verts and the UVs out of it. And then they just pass it in that way. And then the vertex shader, they get them here. So no special space for this one, they just pass them through. And then I'm guessing in the fragment shader, where they get it as input, they just use it to sample, yeah. So if we modify our code to actually pass in UVs, like I don't think I can do just an in and then not bind any UV. I think if you don't do anything, it'll kind of automatically pass UVs into the fragment shader. But the moment you say like I think I'm gonna have to really get rid of this this weird extension. Don't really like what it's doing. Like I start typing and it inserts new lines for me. It does like auto formatting. It's not the right tool for the job. Oh no, actually for input data, I don't need locations. What do they call this again? Vertex UV? So now if we did this, we'd have to pass in and bind vertices here. I'm also going to want to pass in colors. Right now I'm setting it to white, but like I had said before, I'm going to want to be able to pass in a brightness. So I'm going to do that probably by encoding it in the color itself, or passing in. Actually, no. Probably I'll just pass in a. What will I pass in? Yeah, maybe for each vertex I'll pass in like a floating point value for brightness. So we'll just get a sample, like we'll just get a value here, and we'll pass it to the fragment shader, and it'll be interpolated. And that could be kind of interesting, because we could do this, like if we were so inclined, we can say like, oh, we know we're drawing a line from left to right, and we could say, make the first point slightly darker than the end point or something. Although I probably won't do that, because we kind of build our lines piecewise, so that wouldn't look right. I would have to kind of, and that's something I've been thinking about as well, is right now what we do is every frame that we're pumping as fast as we can, if the beam is moving in a straight line, we're just building small segments of lines. But we could, I was gonna say we could combine those. Nah, that wouldn't work. Yeah, no, forget it. Anyway, at the very least I would pass just a brightness value for that line. And that doesn't really change. That's like the brightness setting that was set for the beam that's drawing. So okay, like just doing this, for example, I think we're gonna see this. It should break, and it doesn't break. Interesting. Oh wait, I'm in the fragment shader. This is not the right place. It should have been in the vertex shader. That's why it's actually not broken. You know what? I'm gonna stop right now. Tools, extensions. this thing here. Okay, now I won't have those formatting issues anymore. So like if we did this and did that, we have to say that there's an out vec2 UV. So now if I'm not passing in UVs to the shader, I think it will work for some reason. Draw vectors. It's like totally ignored for some reason. What am I missing here? Out vec UV, in vec2. It's the same. It's the same. Writing here. And then when we go to the fragment shader, it has an in vec2 UV. So if we go to the fragment shader, oh, this is supposed to be in, that's why. This is the draw vectors frag. Oh, actually, it's not here that we care about this. Yeah, no, this is the wrong one. Draw vectors is we're just drawing vectors into a texture. It's actually going to be here in the pass-through, because then the pass-through is the vertex shader that goes to the. It's a bit confusing, but we pass through the vertex shader, and we have this draw texture fragment shader, and that's where we actually care about this. Okay. Confusing. So yeah, here we'd say pass through vertex shader. Gets a vertex UV, yeah, and then out here. Okay, so there's already a computation here on the UV. Taking the vertex position in model space, add 1, divide by 2. That might answer the question, right? How come it's working? It's using the... Ah, okay. That's it. That's the answer. Cluewash, you were wondering? The UV is being computed here, because it's not being passed in, it's being computed based on the vertex position in model space. It's using the knowledge, just as coming from that example, where it's using the knowledge that those vertices are basically coming from the full screen triangle, you know? Yeah, that's where it came from, exactly. So okay, so then in that case, we could just modify it here. Just undo the mess I was doing here. So that's fine there. Okay, that's fine. So here, basically we're saying divide by 2. So like if here we were to divide by bigger than 2, let's say 2.5, just to see. Whoa. Did I mess that up? Vertex position, model space. We're adding 1. Let me go see again in the GL render. Okay, because the triangles are defined in -1 to 1 range. So then this is basically bringing it into the 0 to 1 range. Hence the adding, offsetting by 1, which brings it to 0 to 2, and then divide by 2. I would have thought that I'd be able to then do something like this. Oh no, that's it. Same problem, right? We'd probably want to do that beforehand to scale it, right? So if we scale this XY here and then do the addition. Is it again the other way around? I might have to split the... I'm sharing this vertex shader now for both the overlay and the other one, but I'm not sure why this isn't working. Oh wait, yeah, no, I should do the right thing. I can't seem to wrap my head around this. Because now I'm in the vertex shader, right? So we know that the vertex positions we're getting are in model space, right? So these are these values right here. Now what I'm trying to do is I'm saying, okay, we've got this now as a proper UV coordinate in 0 to 1. If we take that UV coordinate, so shift it into minus 0.5 to 0.5, so it's centered around 0, scale it, right? In this case, say by half, So like if it was 0.5, it would become 0.25. Then add back 0.5, and that would become 0.75. So instead of 1, if originally it was 1, I mean, it becomes 0.5, 0.25, 0.75. This time we're not talking about sampling, we're actually talking about computing the UV. Oh no, it's not the UV we want to change, it's the actual position, isn't it? I'm making the same mess. Okay, so this is closer to what I wanted, but I don't know why it looks crazy inside here. Oh, it's feedback, isn't it? Some kind of feedback problem? Is it? No, not really. Oh, yeah. That's interesting. Yeah, okay. The reason why it keeps getting smaller and smaller is just because of, what I'm doing is I'm not clearing the buffer and starting from scratch. I'm taking the last output and darkening that, right? So it is a feedback problem because I'm taking a render to texture that has been rendered smaller, darkening that, taking that back, and then rendering it smaller again. And so we're getting this all over and over. It's getting the part of the game screen without not the overlay part, but the game screen part is the part that we're constantly reducing in size. Right, so that explains that. So in that case, what we probably need to do then is split so I've got this pass through here that I'm using in both cases. Kulash says it's actually kind of cool if it were implemented on purpose. Yeah, I suppose. See, I'm using this pass through twice. But actually what we want to do is we just want to make it smaller when we do the texture to screen, right? So like instead of pass through here, I can call this, draw texture or something, and make a draw texture vert that does this thing. But even that won't work because we're using the same vertex shader. Yeah. Oops. What do I do? I might need a separate pass for the overlay. Right now I'm like kind of, using draw texture here, this fragment shader, to do both, to sample both and to draw and mix them together and get one output in one shader. Unless what I do is I pass the scaled value through the shader here. And then at that point, it just begs the question: why am I not just, if I'm gonna do it that way, why not just scale the verts I'm passing in at the outset, right? Could I do that? No, it's the same problem. Yeah, this is not working. Because I have one quad to which I'm rendering two textures. So I guess I could draw two quads. Is that the right solution? I'm not sure. I'm thinking about different ways to do this. Like, I'm thinking that I could do, there's multiple ways. I could do like another pass where I render the like the reduced, like the game screen part could be rendered again to a texture, but this time smaller. But do I really want to do that? No. I'm thinking more like I want to render to just a smaller quad and then have like two quads, one for the screen and one for the overlay. And if I did that, could I just do that with the same shader? But I guess I would have to do two draws. I think that's the trick, is to just do two draw calls. And then in the draw call, it's we only sample the one texture we've bound, and we do the alpha blending. Like, I mean, we use alpha when drawing it, so then the overlay will just basically be drawn with alpha on top of the frame buffer. I think that's the right way to do it. But let's try it. So instead of doing what I'm doing here, where I'm binding two different textures, we'll just bind, let's say, the first texture, which is the rendered texture, the game screen. I'm going to do a little bit of copy paste here. Actually, do I need to? Yeah, okay, whatever. Yeah, you know what? I'll do we'll pass in the ID of the texture we want to bind. And just as a start, we'll do it this way. We'll say that we're binding. We'll forget about overlay alpha for now. G overlay texture. Oh, did I like lose my other one? It's rendered texture 0, I think it is, yeah. Okay, so we do this. I don't think this will actually work just yet because I'm sampling from a texture unit that's not there. But it does build. Okay, yeah. And now we'll go into draw texture here. So we don't have a overlay texture anymore. Can the color be a Vec4? Is that valid? Kluwash says yes, so it will get the alpha channel. Whoops. Oh, there's a syntax error, okay. 21. Oh. Okay. Kluash says yes, but you might have to do some transparency handling on the outside. Yeah, I'm wondering about that. Like if I don't pass in transparency, like alpha in my texture, like the buffer that I make, if I don't pass it in, does it end up being 0? That probably is what happens, right? Let me see here. So what I did is I modified the draw vectors fragment shader so that it outputs 1 for alpha. So we'll draw like all the lines and all that, we'll draw them with a 1 alpha value. So that should end up in the texture. Now, is my texture an RGBA texture? That's the next thing to check. RGB 32F, so it would not have alpha, right? Can I do RGBA 32F? Looks like it. Try it. Just to be sure, is that, you know what? I should be not drawing the second pass just yet. Let's just make it without the overlay and see if we actually get our screen. Okay, that's a good sign. And once we draw the overlay, we get the full overlay. Flash says I need to enable GL blending. Really? Like you're saying like the way OpenGL will render stuff to the to the frame buffer has to be set up. If I'm gonna be doing multiple draws to the same frame buffer, what it does to the existing pixels is controlled through the GL blend stuff. Yeah, you're right. GL blend func. So initial value is GL1. So I probably have to do something like, 1 minus, or was it 1 minus destination alpha or something? 1 minus source alpha, 1 minus destination alpha. I always forget what it is we really want here. I guess we want to specify it for a single draw buffer, technically. So actually, if I do it this way, I could not pass alpha for the first one. If we say that it's 1 and then 1 minus source alpha, I think it is. 1 minus source alpha. Clark says, well, you could do the blend calculation by hand in the fragmentator. So that is what I was doing, right? Oh, do you mean that? Because right now what I'm trying to do is I'm trying to use like the same fragment shader on the same frame buffer, but drawing twice on it, right? And so the output color here, this guy here, like this is not an input, it's just an output, right? So I can only supply a color, and then what it decides to do with that color into the frame buffer is controlled by the blend function, which I think is what you were saying earlier, and I think it's true. Otherwise, what I would need to do is just like what I said earlier, which is just add an extra pass where we draw the final result that I have right now in a texture. I need to keep it in its original size so that I can keep darkening it and not avoid the feedback problem, but just add yet another texture that we render it to, but scaled down. And then after that, when we sample that texture normally, like with the original code I had, we'll get the right thing. I'm just curious if I use source alpha and 1 minus source alpha, what it looks like just in general. So that actually works. Okay, that's cool, right? So let's say, I'd set it globally because, I mean, it's fine that we do it for all the frame buffers. It actually makes me think, again, I don't really need alpha. Then in that case, if I'm drawing to the frame buffer, I don't really need a 32-bit float buffer with alpha, right? Because that's the first thing I draw. Yeah, I think that's true. I think if I bring this back, does that work? I think it assumes 1 for alpha, yeah. And if I come back to draw vectors. Draw vector, not draw vectors dot vert, draw vectors dot vertex shader. It's here, draw vectors dot. Like this guy here, I think can remain a vec3. Let's see. Yeah. So now what this allows, so a really important part was this final draw texture here. Making this an output 4 is important. If we go back to 3 here, I think we're going to go back to having the whole thing fill the screen. Yeah, exactly. The important bit is right here. By keeping the alpha channel of the texture, we get the blend that we want here. And now, I'm not saying I like this solution, although this is, you know, an optimal solution, but I don't like the kind of like lack of control, because we're letting OpenGL handle the blending, and I kind of like doing it myself in the shader, but it means adding an extra pass, which I might do anyway, especially because I'm gonna want to do the warping I was saying with the UV, and so I'm gonna want to do that when I render my game screen texture into another texture, smaller and warped with UVs. That texture there, to do that I would want to have a separate shader for it. So yeah, this is not going to be my final solution. But having said that, let's just see if we can at least achieve what I've been trying all this time. It's just to kind of scale this quad vertices here. Okay, so if we scale, if we pass in a scale value here, and we say here, 0.5 and then 1, let's see what that gives us. It gives us bad compilation. Conversion loses qualifiers. Okay. Oh, it's a const buffer. Okay. Let's not make it const. Oh yeah, and it can't be static either. Is that right? Oh yeah, transform just needs to return. Okay. Strange. So it is doing the scaling I expect. Don't understand what is going on. It's not complicated what I'm doing here. I'm just saying to take the scale and apply it to these values here. This is all centered around 0, 0. And we saw in the debugger here that when I do that, let's say, 0.8, we're going to get, I said debugger? No? Doesn't like it. Let's try and debug. You know what I should do? I should put an imGUI float slider around the scale. Okay, so like here, see the range went to -0.8 to 0.8 instead of -1 to 1. So those would be our quad vertices that we are sending, we are setting as our vertex buffer data here. So that's what we send, and then draw vectors vertex here. What? So that's it. It should basically be taking that and setting the position. In clip space, sure. That should have worked. I just added a slider for imGUI here. Did I not do that right? Oh, should probably pass in the scale. Okay. Okay, so you know what this is? This is the calculation of the UVs. That's what this is. See, imGUI helped me understand. Thank you, imGUI. I knew that it would be helpful for debugging. So this has to do with the fact that we're computing UVs here, wherever it is. He's a good guy, imGUI, right, Kluash? So yeah, the problem is that draw vectors vert is computing the draw vectors. Using texture to screen. Okay, so yeah, that's it. Texture to screen is using the pass-through. So if we look at pass-through here, this is the one that kind of auto-computes the UV. based on the vertex position in model space. So yeah, I think that's it. There's an assumption being made here, right? That it's in the -1 to 1 space, right? So to fix this, we really should be passing in our own UVs. Let me think a little bit about this. Yeah, because what's going to end up happening here is we're just going to be mapping. Okay, that's it. So let's say, for example, I was doing 0.8, right? Okay, this makes sense. So if I could draw... No, not that. So like normally when we draw our quad, right, which is actually two triangles, but let's just say it's a quad. What's going to happen here is it's saying use the position to compute a UV. And if the position is 0.8, like minus 0.8 over here in the corner, let's say, no, sorry, this would be, let's say up here, it would be 0.8, 0.8, right? Then all we're saying is the UV coordinate here is 0.8, 0.8. And what we really want is for this corner to be 1, 1, right? So that the texture gets basically, we want the texture to be UV mapped completely to the corners from 0, 0 to 1, 1. By making the UV coordinate match the vertex position, what we're doing is we're saying, like, if we draw, let's say, I don't know. That's terrible. Let's say an object like this. So like, let's say this was actually the original with from 0, 0 to 1, 1. That's not good. There we go. Some kind of star. And what we want to do is we want to resize. We want to make our quad smaller, right? If we, with the current UV calculation, it's going to just basically keep the star like this, because this, let's say, is 0.8, 0.8, 0.8, and this is 1, 1. We're saying the UV is 0.8, 0.8. It's going to sample in the texture exactly at this spot, and so we're going to get exactly what you can see here. In fact, what we want to do is we want to say, no, this is actually 1, 1 in the texture space, which would basically like move this, oops, this star. It would move and scale it down into here, you know, something like that. Anyway, I don't know if that was a good explanation, but yeah, all that to say is that computing it based on vertex position is not helpful here, unless we know that it's some factor, and like we factor in the scale here. But we can't without passing that information in. So I mean, like, we could do it rather than scale it on the outside here. We could pass in a scale, or we could just pass in UVs directly, which is probably the right thing to do here. Is pass-through being used? It's also used for darken texture, so I'd have to pass in UVs in both. And I think for this we just are supposed to pass it through, right? Like that. And then in here, Did I use a Vec2? I think so. -1, -1, 0. This actually could have been Vec3s, I think, as well. They're gonna end up being packed. I think it's done on purpose for these to be packed together. So, okay, let's see if we can figure this out. So -1, -1, 0. So that's -1, -1. So let's say that's, I feel like I need to draw this. Be a little easier. This is -1, -1 here. Then the next point is 1, -1. The next one is -1, 1. And then it should go back to -1. Oh, sorry, that's it. 1, 2, 3 vertices, right? Like that. So for the first one, we want zero, 0. This would be 1, 0. And this one would be 0, 1. So 0, 0 followed by 1, 0 followed by 0, 1. And after that, it's going to go to -1, 1. Then to 1, -1, 0. 1, -1 like this, and it's going to go up to 1, 1. Okay, so this is 1, 0 in the UV, this is 1, 1 in UV, and this is 0, 1. One and 0, 1. All right. Okay, so I got the quad UVs here. I don't remember. Alright, so I'm going to need to create a buffer for the UVs as well, just a normal buffer. And send the buffer data in. Yeah, I don't know why I called it set vertex buffer data. This would work regardless. I should rename that. Because this will, where was I? Yeah, this is a misnomer. It's more like set buffer data or something. At least in the case, in this case here, it is expecting vec2s. What am I calling it with vec2s? Right here. Huh. Anyway. Oops. So we do that. And later on we say we bind, we enable the vertex attribute array 1, we bind it, and then we do the same kind of thing. So this works here. I'm going to have to do it also up here. Oh yeah, and I'm going to have to disable it afterwards. Alright, let's see if that actually works. Not quite, but almost there. I must have gotten one of my UVs wrong here. This looks right. we can see now that the scaling actually is working. There is something odd going on here. I'll look at that, but at least now we can see that by setting our own UVs and then scaling the rect, it's doing the right thing, you know? Yeah, this all looks the same. And for me it's dynamic draw, which is because I'm creating them on the fly, so that's correct. Is there a difference between these two? Just curious to see it with the overlay. No, so I mean, I'm doing something totally wrong here with the UVs. What am I doing wrong? Like -1 corresponds to 0, 0. Then 1 - 1 corresponds to UV1, 0. Yeah. And then -1, 1, which is top left corner, is UV01. Then after that we do the second triangle. So we do -1, 1, which is again the same as before, right? Wait. getting mixed up. So this is actually 0, 1. There we go. 0, 1, and then this is 1, 0. There we go. And then 1, 1 in the top right corner. I was getting confused. For some reason when I was doing the second one, I was thinking in terms of like the first quadrant. I mean, I was thinking in like Cartesian, and I was not thinking about UV space. So this, okay, this should work now. Whoops. Let's see. There we go. Cool. Now we're still seeing scaling artifacts, which is expected. So that actually, you know, if we're going to be doing scaling like that, you know, we're going to want to play with the minification filter. Right now I have it set to nearest neighbor, which is why it looks like that. And if we change it to be linear, then it's going to look blurry, but at least we should see more of the lines, right? I think it's the only place where we play with this. Let's try. Whoops. So we set the min filter because it's getting smaller. Don't need to set the mag because we're not zooming in, I think, so. Yeah. See, that's already better. Yeah, so I really don't know what size it's supposed to have. It could be like this, right? Where we can still see the ships and the score. You know, I don't think it's like this. I really have to, you know what I gotta do is I gotta take out my Vectrex and just look. Although, do I have the Mindstorm overlay? Anyway, I have other ones we could use to test. Okay, so this is interesting. So it's not a total loss of work. I am going to keep the UV stuff that I've done, but I'm not going to be keeping this method of controlling the scale because I'd like to do away with relying on the blend function for the frame buffer and doing it myself. So I'm just going to add an extra pass, like I said earlier. You know what? Actually, now that I have this, let's see something. Let's see if we can make that really cool tank game fit, right? This is what we were looking at last stream, and we saw that Armor Attack, which is this really nice tank game, has a very interesting overlay that is supposed to line up and match with the buildings that are drawn by the game. So let's try that again. So here's Armor Attack. This is the ROM. So we pass that, and I'm gonna go change the overlay that we load. Instead of loading mine, we want to load Armor Attack. So let's hack that in. And let's see what this looks like. Oh, did not. Oh yeah, I gotta put the path. Overlays. Overlays armor attack like that. Okay. So that's armor attack. And I'm gonna leave it like this just as to show, but this is like right now the game does not line up correctly, but if we do this, so it looks like it's not just a linear scale that we're going to need to do. We're going to have to apply some kind of offset. Because what I'm expecting, and I'm looking at here, yeah, we've got some kind of offset, it seems. I think. Unfortunately, I don't own this game, so it's hard for me to know for sure. Very strange. Because I'm looking at this and even a scale won't do the trick here. Let's see if we can find it online. Maybe someone has a... Oh, okay, so even on the real Vectrex, it's like not lined up at all. It doesn't look lined up. I mean, we're at an angle here, but still, like... That's messed up. So can mine look something like this? Oh, the game just stopped. One thing I'm noticing is actually that here it looks like it fits better. There may be a problem with the way I'm doing my perspective stuff here. Looks like mine is more like narrow, not quite the right aspect ratio. You know, it may just be the curvature of the screen thing, maybe. I don't know. It's hard to say. It also looks like my overlay doesn't quite match what we see here. Not exactly, anyway. But there's something going on here. Like we can see, like for example, in the center, it's pretty good, but out on this, on the lower edges here, for example, it should overlap this one a bit more. Could this really be because of the curvature of the screen? Like, is there that much warping? Maybe. I don't know. Like, in a way, it kind of makes sense that the outer edges are affected by, like in the middle, we're pretty lined up, but as you move to the edges, in fact, left and right edges look a lot like this, but it's as you move to the top into the corners that it doesn't quite line up. And I guess maybe that's explained by the curvature of the screen. Like, actually, there's these like kind of dotted green lines around that seem to follow the border of the game, right? And for me, it's very hard to see, actually. I don't know why, but it doesn't show very well. But the dots are there, but they're not quite following the game lines. These lines rendered by the game. Game restarted. And actually the bottom here is really off. Feels like it wants to be more like this. Yeah, there's something going on here. I need to think a bit about it. Still, looks pretty cool. Still can't turn left. All right. You know what? I think I'm gonna stop here. I'm gonna clean up this code and do the extra pass I was saying at probably some point between now and next stream. And I'll think a little bit about this distortion that we're seeing. There's a few things I'm thinking about, like how what I'm doing is in my GL render here. So in terms of the Vectrex, it sees the display as a 256 by 256 display, right? That's how many, you can think of, like that's the screen space. It's a square screen space. However, the screen is not square, right? It's got a 4:3 aspect ratio, but it's actually rotated, so you can think of it as 3:4. And so what I do is I use that when we set up the viewport and we give the window size. When I compute the projection matrix, I compute the projection matrix in terms of the Vectrex screen. So that's the 256 by 256. So that basically I'm saying that that space is square, right? But what? But okay, so yeah, sorry. So that's the projection matrix. So it's saying project the square 256 matrix. Sorry, I'm saying this wrong. Take the vectors that we are rendering in this 256 by 256 world and just create a projection matrix that projects it as though it were square. So if the window were square, everything would be square. But the window isn't square. There's warping. And the warping is just basically the fact that it's supposed to be squished. And that's what we have over here, where I give a default window width and I have a window height from width where I just basically multiply by this aspect ratio of 4/3. And so all that's doing there is saying, if we want to mess around with the window size, we're just going to make sure to keep that aspect ratio. And that's what I had read. I had read that basically, although there is a square game space or view space, whatever, that it gets basically warped, like what's the word I'm looking for? Scaled non-linearly to fit the screen, if that makes any sense. But maybe that's not right. Maybe what I read is incorrect. Because like when we look at these images, they look more square than what I've got, Like in fact, if we just did like, just return the width here. So the height and the width are the same. And actually make it valid code. Cool, since you're rendering on a texture, maybe you could kind of model a real screen as a 3D model and project the texture onto it. And you're laughing. Actually, I totally thought about that. Like actually make a mesh, right, for the screen with UVs and everything. Like just model it in a modeling software and try to really make a real looking, a proper mesh for the screen. We could. We could do that. I thought that was kind of maybe overkill, but I thought maybe it would be better to do it using computation. What I meant is like we could probably figure out a computation based on the, I was thinking like taking a slice out of a sphere and cutting out the sides, we might be able to get something similar. Otherwise, I'd also, like I'm not a modeler, so I don't even, I'd have to like learn, Blender and something, and I could do that, but. So yeah, so here I was gonna say like, okay, let's just comment this out here. Kluash says, me neither, haha. Yeah, I watch artists at work in these tools, and I'm always amazed at what they can do. Okay, yeah, so you can see like this is totally messed. That's kind of telling, actually. It seems like is it telling? I think it's telling me nothing. It doesn't look right at all. See, it's like way too square now. But you know what I'm thinking? Okay, yeah, you know what it is? Yeah, okay. I think I understand. It's because it's a different aspect ratio for the overlay than it is for the game screen. It's a different. There's a different projection, basically, that we would need to compute. We need to get like the ratio between the overlay and like the game screen. You can see it here when you look. That you have the television, the CRT here, and like the distance between the top here and the bottom here and then the left side here, they're not. It's not all the same. It's not linear, you know. So that's what this is. I just need to get the proper scale factor here and like, you know, either change the projection matrix for the overlay or kind of maybe what I'm going to do is I'm going to just tweak that into the scale factor that we'll use to scale the game screen. Right? It's not instead of doing a linear scale, we're going to do a non-linear scale for in terms of height and width. And I think that would work. Yeah, if basically instead of doing, right now I'm just doing like a linear scale around the origin. We just break that down into two components, scale around the X, scale around Y. We play with both and we should get this, actually that would be pretty easy to do. And hey, I have 8 minutes before midnight, so tons of time. Kluar says, I would totally go with the computation. Yeah, I think that's what I'm going to go for because that's all I'm good enough at doing. If I was an artist, I might try my hand at making this mesh. Then, you know, it's an extra resource to load and worry about. And feeling kind of lazy there. So what do I want to do again? Oh yeah, I wanted to see if we scaled on the two axes separately. Let's say we did like scale X and scale Y, right? Okay, I don't think I'm going to use transform then. So if I modulo 3 is equal to 0, we're dealing with an x. So we'll say take quad vertices of I and equal to this multiplied by scale x. In fact, what we'll do is we'll say switch I modulo 3. Case 0, so that's for x. Case 1, that'll be y. And for z, I mean that's 0 anyway, so we don't care. So let's just do nothing. I'm going to have to pass two values to our function. I need some breaks. Alright, so let's do here scale X and scale Y. Scale X, scale Y. Did that in what, like 2 minutes? Now we can play. Alright. Cool. Let's see if we can get this to look sort of right. So we'll go to 1, 1. And I'm thinking there must be an offset to apply as well. Although this is pretty close, actually. Although the bottom here is not right.
I love the power glove. It's so bad.
Like this? Oh yeah. That's pretty good. This looks like the bottom picture now. I mean, this looks like this picture here. Yeah. Interesting. So you see, with a scale, so scaling in X is about 0.9, and scaling Y is about 0.75. That seems to give a much closer looking image to what's over here, if we assume this picture I grabbed off Google Images is right, but it looks pretty good. It's very finicky. It requires very little change to make a huge difference. Yeah, this looks good. So it's something like this. So as for the blurriness, right, now that we've got this minification linear blending, right now it shows a lot when we blur. Like you can kind of see like there's some parts of the lines that don't look quite nice, quite right, but this is because I have yet to do the glow that I would like to apply, right? And when I do that, rather than have these like thin, you know, like single pixel lines, we're gonna have blur, like you know, thicker lines because it's supposed to glow. And then when we scale that, we should see more solid looking lines than we have now. So I'm not too worried about scaling here. Like the scaling artifacts we get are going to be less obvious or minimized once we stop doing this kind of just straight line drawing and do a little bit of glow, a little bit of blur to our image. And so I think with that I'm gonna call it a night. So guys, thanks for watching. Kluwash, thanks for hanging out. And yeah, I'll see you guys next Monday. So yeah, thanks.